among the discussion points in my world is what's the difference between HDR and SDR? And can SDR approximate HDR?
Mm-hmm.
And of course, I'm actually in the camp that SDR can actually do better than HDR. But at the moment, I'm concerned that everybody considers that heresy. So we're trying to sell HDR sets. What do you mean SDR can be better?
Well,
and
this is quite surprising to me too, so I would like you to elaborate on this. How is it that SDR can actually perform better than HDR?
Well, part of it is the actual dynamic range within a signal for HDR is quite a bit smaller than the dynamic range for SDR.
How can that be?
Oh, and it has everything to do with the perceptual quantization curve, the PQ curve that's used for HDR. That curve is an absolute curve, and I actually think I have a graphic of it.
Yeah, we have several actually.
But the one with the 50% is the PQ50 is probably
it's called PQ50, yeah.
That's probably the best graphic to put up at the moment. But the PQ curve is an absolute curve. Over on the left-hand side is the light output. Now that 10 at the top is 10,000 nits. The 1 is 1,000 nits. The 0.1 is 100 nits. And of course, 0.01 is 10 nits.
Mm-hmm.
But that's an absolute curve. Along the bottom is the signal in. So what happens is when you put 50%, a signal that it has 50% of the dynamic range, it comes up to 100 nits, which is the standard light output for a standard dynamic range TV set. But if you put 100% in, it goes all the way up to 10,000 nits. But there isn't any display that goes to 10,000 nits. If you look really carefully at this diagram, you'll see a line coming out of the yellow line at the 1,000 nit level and then going across and being absolutely flat. In other words, TV sets...
We actually have a picture of that called, what is it called? PQ limits, it's called.
Yes.
So let's take a look at PQ limits.
All right. What you see is if, as an example, you have a display that only has 300 nits output, you can see if you look that lower line is right about 300 nits. Mm-hmm. And what happens is nothing in the signal can go above that, or it will get clipped. Or if you're at the 1,000 nit level, nothing can go above 1,000 nits without being clipped. So what that means is someplace between 63% and about 75% of the signal is the maximum amount of range in that signal you can use for the video. So the video can only go from 0 to a maximum of 75%, where in standard dynamic range, the video can go from 0 to 108%. So,
and we can take a look at that curve. That's called the gamma curve, and I believe we have a photo of
it. Basically, what happens is in the standard dynamic range, I can use anything from 0 to, and that curve keeps right on going. It goes past 1, and the video dynamic range allows me to go to about 108%.
Mm-hmm.
So I can use anything from 0 to 108% for a standard dynamic range signal, but I can only use something from 0 to 75% in a high dynamic range. So
if you're using PQ, if you're using that particular...
Yes, because that's what is being used for high dynamic range.
For the most part, yeah. I think exclusively, I guess. There is one other curve.
There is the hybrid log gamma curve that is being proposed by the BBC and NHK, and it's a hybrid between the gamma curve and the PQ curve, but it also has it also has those upper limits in it. And
Oh, I thought it was relative like gamma. Is that not true?
Well, it's relative like gamma at the bottom end of the curve, but
Ah,
it's fixed like PQ at the top end of the curve.
thus the term hybrid.
Yes. Great.
Very.
See how easy these names are in describing what they're doing.
Yes, indeed, indeed.
But anyway, so a part of the PQ curve is used in the hybrid log gamma system, and all of the PQ curve is used in the Philips Technicolor system, the Dolby Vision system, and the HDR10 system. So the other three systems use the PQ curve. Dolby might have an argument that theirs is 12-bit instead of 10-bit, because in fact Dolby is using a 12-bit system instead of a 10-bit system. So theirs might be HDR12 instead of HDR10.
You might be able to call it that, right? HDR10 is simply 10 bits. But this the bit depth brings up another question for you regarding this amazing statement you have made that you actually prefer SDR, can look better, I should say, over HDR, and that is bit depth. I mean, if you're going to use the SDR gamma, relative gamma, to increase the dynamic range of an image, because we now have much brighter TVs, don't you need to increase the bit depth as well?
Well, I'm advocating SDR at 10 bits.
Ah, okay.
I'm certainly not advocating it. Yeah. Yes, that wasn't qualified. Yes, I am advocating that SDR have the same 10-bit system that the HDR has, and I'm advocating the same color for SDR. You know that part
BT709, really?
No. HDR is P3.
So it is.
Almost everything, at least in HDR10 and Dolby Vision, the color for HDR is P3. And so I'm advocating the same color for SDR.
I understand. Okay, I got it.
I'm advocating a 10-bit system, but you see, I'm using much more of that 10-bit dynamic range than the HDR system is using. I'm using a lot more of the dynamic range. So when I make comparisons, there is less contouring, the banding that you see in pictures. There's less contouring in the picture in the SDR image than in the HDR image. There's one other important point. Almost every consumer HDR display has a problem of light output versus how much of the area of the picture is being lit up. If a large part of the picture is being lit up, then you can't make the 10,000 nit levels. The
1,000, you mean? You mean the 1,000?
Yeah, the 1,000. Yes, I'm sorry. Yes,
there are no consumer TVs that can do 10,000 nits anywhere near it.
Yes, thank you for the correction.
Yes.
But what happens is they can't reach those levels. So
if a large part of the image is very bright, say a snow scene or something like that,
just a day scene, just an average day scene. Look at the scene behind me. That's a high average picture level. There is a large part of this picture that is bright, and so if you look at the image behind me, that is way too much for 1,000 nit levels or 500 nit levels or 300 nit levels, whatever you're going to get out. And so if somebody does something like the scene you're currently looking at, if they do it in HDR, the maximum light output is going to be 500 or 600 nits anyway. And so what happens is in SDR, you can run up to 500 or 600 nits, but you can have the entire picture filling the screen at 500 to 600 nits. So when you start looking at real picture content and the fact that some pictures do have a lot of light, bright area in them, then the SDR comes out looking better than the HDR. And so and I know this is heresy. We've been talking about this, but when I come out with a UHD Blu-ray disc in conjunction with Florian Friedrich in Munich, when we come out with a disc, what's going to happen is there's going to be SDR images on there, and we're actually going to encourage people to look at those SDR images at 500 or 600 nits. And then the exact same images are going to be in HDR. So they'll be able to go back and forth between SDR and HDR from the same 10-bit P3 images and look for themselves to see what the difference is.
I can't wait. That's going to be fantastic.